Hi everyone, welcome back. I hope your first day of instruction went super well and you had a good first day and were able to find everything. We're going to be moving into our second lesson, which is Unit 8, Lesson 4 today. So just like yesterday, you want to make sure first that you're set up with everything you need. Pretty much the same as yesterday. You're going to need paper or some sort of notebook to take notes in. You need your classwork on Google Classroom that your teacher should have gotten you set up with. You need a pencil, and then today you also need a calculator. You can find a calculator online if you don't have one at home to use. So just go ahead and take the next 30 seconds or so to make sure you're ready with everything. A reminder to also update your paper so that it has today's date, and then the header Unit 8, Lesson 4, Mean Absolute Deviation, abbreviated MAD. Take 30 seconds to do that right now. Okay, and we're going to be jumping into this next lesson. Before we jump into today's lesson, just wanted to do a quick review on what we learned yesterday. Yesterday, we talked a lot about box plots and specifically how to analyze box plots and use them to compare different data sets. And today, we're going to be moving into a new topic, which is mean absolute deviation, which is another statistical measure. Before we do that though, I want to make sure you're super good at something you've already learned, which is calculating means or averages. So remember that the average is the total of all of the data points in a data set divided by the number of items in that data set. So here you can see an example of the top 9 scores on a weekly quiz, and to find the average, you add up all the scores and then divide by the total number of items, which is 9. You're gonna have an opportunity to practice this right now just to make sure you're feeling super good with it. So your first question right here is to go ahead and calculate the mean of the following 3 values: 34, -12, and 17. Your teacher's gonna pause the video and you're gonna go into Google Classroom and enter the mean for those 3 values. Go ahead and do that now. And you should have gotten, if you did this correctly, an answer of 13. To get this, you're adding 34 plus -12 plus 17 and dividing by 3, which is the total number of values. Okay, if we take a look at an average for a data set, this is something called a bell curve, which is another way to represent data. And you can see that the mean or average is actually a statistical measure of center. You can see here that this line corresponds to the mean or average for this set of data points. Today, we are learning a new measure, a statistical measure, which is called MAD, or mean absolute deviation. What mean absolute deviation is it's a measure of the average distance of each data point from the average of all data points. And that sounds a little bit complicated, but we're gonna show you how to calculate it soon so it'll be really clear. So when we look at this on a bell curve, like we just saw, imagining that these are all the data points in a data set and our average or mean is right here in the center. For a given data point that's closer to the average, like right here on the curve, this is a small distance from the mean, okay? Then as you move further down the curve, you can see that the points near the bottom of the curve are further away from the average or mean. And so now there's a larger distance between this mean and the data point. And so taking that into consideration, I want you to answer this next question. Let's imagine we're taking the average from our first question, which remember was 13. Which of the following 2 data points has a greater distance from the mean? Is it 9 or 20? Your teacher is going to pause the video and you're going to go ahead and enter your response in Google Classroom right now. Go ahead and pause the video now. And you should have gotten that the answer for this question was 20. When we write down the answer to this, you know that 9 is 4 away from the mean of 13, but 20 is 7 away from the mean of 13. And so 20 is further away or has a greater distance from the mean of 13. Okay, so now that you know what MAD is, I'm going to teach you how to calculate it step by step. So I want you to consider the following problem. Below are the number of likes one student got on the TikTok videos they posted this week. find the MAD for this set of data. So here you can see my data set. Student 1, their TikTok likes, they got 70, 65, 75, 80, and then 88. So the first step when you're calculating MAD is something you already know, which is just calculating the average of the data points. So here I'm adding up 70 plus 65 plus 75 plus 80 plus 88 and dividing by the total number of data points, which is 5. This gives me an average of 75 and 6/10. That's step 1. Step 2 is where we start to learn some new stuff. So pay attention really closely here. The second step is to find the absolute distance of each point from the mean. You might have noticed in the term mean absolute deviation that there's the term absolute. And you're probably familiar with this because it probably reminds you of absolute value. Because we're calculating a distance here, we want to make sure that we're using absolute value because we know that all distances must be positive. So for this step, basically what you're doing is you're taking your average from step 1 and you're finding the absolute value of the difference between that average and each data point. So breaking this down a little bit more, first data point was 70. I take the absolute value of 75 and 6/10, which was my average, subtract 70, and I get a distance of 5 and 6/10. And you can see that I did this for every single data point in the data set. As you go further down, you can see like when I got to 75 and 6/10 minus 80, I got a negative value, but because I'm taking the absolute value, the answer ends up being positive. And you want to make sure that all of your distances are positive when you're doing this. The last step is to find the average or mean of those distances. Okay, so now what you're doing is you're taking all of the distances you calculated in step 2, you're adding them up, and you're dividing again by the total number of values. So in this case, I'm taking 5 and 6/10, 10 and 6/10, 6/10, 4 and 4/10, and 12 and 4/10. I'm adding them all up, and then I'm dividing by 5. Notice here that the total number of values for my first step in the average and for my third step when I'm calculating the MAD are the same. This is really important because the total number of values hasn't changed between those two steps. When I do this last step and I add up all the distances and divide by 5, I get an answer of 6 and 72/100ths. And this represents the MAD, or the mean absolute deviation. Make sure you have this all down in your notes. We are going to be practicing this now, and you're going to be doing this on your own. So make sure you have a clear idea of each of these 3 steps so that you can replicate this process on your own. Okay, so now it's your turn. The lower the number of likes another student got on the TikTok videos they posted this week, your job is to find the MAD for this data set. Here's the data set. Student 2 TikTok likes, they had 95, 97, 100, 95, and 98. You're gonna have 3 minutes on your own right now. Your teacher's gonna pause this video and you're gonna go ahead and calculate the MAD for this data set. Remember, there's 3 steps. First, find the overall average. Second, find the distance of each point from that average. And third, find the average of those 3 distances. You have 3 minutes. Your teacher's gonna pause the video now. Okay, let's review the correct work. You just had some time to work. You should have gotten for a correct answer for this problem was 1 and 6/10. Now let's break down that work so that you're super clear at each step. So remember, the first step was to find the average. You add up all the data points, 95 plus 97 plus 100 plus 95 plus 98, divide by 5, and you get an average of 97. That should have been the easiest step. Step 2, you're finding the distance of every data point from that mean, right? So you notice I started with 97 every single time and took the absolute value of the difference between that average and each data point. You should have gotten for your distances 2, 0, 3, 2, and 1. Then when you add those all up in step 3 and divide by 5, you get a final answer of 1 and 6/10. Now, if you didn't get that right, it's totally okay. Calculating MAD is kind of tedious. There's a lot of calculations involved, and so it's easy to make mistakes. I want to review some common mistakes that potentially you made in calculating the MAD for that last problem. So the first common mistake is not including both of the 95s. So it's really, really important to remember that even if a given value in a data set is repeated, like 95 was in that last problem, you still need to include the same number of total data points in the MAD calculation. So you have to include both of the 95s. This is because, remember, I told you, you started with a total of 5 data points, and that doesn't change when you're calculating the MAD. You still have a total of 5 data points, and you need to include all of them. The second common mistake you might have made is you might not have remembered to use absolute value. Remember when you're calculating MAD that you're always subtracting from the mean, but you have to use absolute value because we're talking about distance, and we know that distance is always positive. The last mistake you might have made is that when you found the distance of 0 in step 2, you might have thought, oh, that 0 doesn't matter, and so I'm not going to include it in my calculation of the MAD. It's really important to remember when you're calculating MAD that every single value counts. Even if you get a 0, that value still counts, and you have to include it in your last calculation. Okay, so now that you guys know how to calculate MAD, we're going to talk about why it matters. So why is this a measure that's really important in statistics, and how can we use it? So let's take a look at those two students' MADs again. Remember, student 1 had a MAD of 6 and 72/100ths, and student 2 had a MAD of 1 and 6/10ths. I want you to answer this next question. Based off of your current understanding of MAD so far, who do you think was more consistent in the number of likes they got for their TikTok videos? Was it student 1 or student 2, and why? You're going to have the next 2 minutes. Your teacher's going to pause the video, and you're going to go ahead and type in your response to Google Classroom. Go ahead and pause the video now and type in that response. Okay, let's go over the correct answer to this question. Student 2 was more consistent in the number of likes they got for their TikTok videos. We know this because the MAD measures the average distance of each data point from the mean, and student 2 had a much smaller distance of 1 and 6/10ths than student 1, who had a MAD of 6 and 72/100ths. This means that overall, there was a lot less variability in the number of likes student 2 got for their videos. So student 2 was way more consistent with how many likes they got each day. If we look at this overall, we can see that MAD is a measure of variability, okay? And if you look at the graph on the left-hand side, this graph has a smaller MAD, okay? It's tighter together, and that means that there's a smaller amount of variability and an increase in consistency. So because the data points are close together, they're more consistent. Remember that variability and consistency have an inverse relationship. If you look at the graph on the right, on the other hand, this has a larger MAD. The points are more spread out, and so there's an increase in variability and a decrease in consistency for this one. And this really leads us to our key point for today's lesson, which is that mean absolute deviation, or MAD, is the average distance of each data point from the average of all data points, and it's a measure of variability. The smaller the MAD, the more consistent the data, and therefore the smaller the variability. Make sure you have this in your notes. It's going to be something that you can reference as you work through your classwork. Okay, as you're moving into independent practice, here's an anchor chart that you can use to help support you. On the left-hand side, you have a definition of MAD and also each step-by-step calculation that you're going to do to calculate that. And then on the right-hand side, you have some of the trends, right, and how you can speak to consistency based off the size of the MAD. For your classwork, you're going to be working on problems 1 through 5, slightly fewer problems today because it takes a really long time to calculate mean absolute deviation. And then your exit ticket, you're going to have problems 1 and 2 to complete. Good luck, and I hope it goes well.